Good morning, sixth graders. So we're going to start with a little bit of review here. If you'd like to, please pause your video and try these problems on your own first. Now we are going to try them together. So 5 to the 4th power is the same as 5 times 5 times 5 times 5. 5 times 5 is 25 times 25. I know 20 times 25 would be, let's see, 500. And 5 times 25 is 125, so that would make it 625. 8 squared is the same as 8 times 8. 8 times 8 fell on the floor, picked it up, it was 64. Over here, we're going to find out our shorthand version. So 3 is our base because it's the number being repeated, and it's being repeated 1, 2, 3, 4, 5 times. 3 to the 5th power. If we scroll down here, we have a couple of PEMDAS problems that we can try. Remember that we always start by rewriting, so that way we remember. We start with our parentheses. 8 times 6 is 48. I bring down the squared because I do whatever's in my parentheses first, and the square is not in my parentheses. Plus 14 minus 6. I use my P, so now it's E. 48 squared is the same as 48 times 48. Ooh, that was tough. 8 times 8 is 64. 8 times 4 is 32. Plus 6 is 38. Placeholder. 4 times 8 is 32. 4 times 4 is 16, 17, 18. 19, 1, 4, what am I doing here? 10, 13, 2. So 2, 3, 0, 4 plus 14 minus 6. We go in order. So I have to add 14 first, which gives me 2,318 minus 6 would be 2,312. We're going to skip this problem. Okay, on to our next assignment here. So we are going to do greatest common factor. Our objective, which we should all pause and put in our notes now, is to find the greatest common factor of two whole numbers. So the numbers that we're looking at are whole numbers, and our goal is to find the greatest common factor. Now, the word greatest here, it doesn't mean best. We're not just going to pick the best. Greatest here means the biggest or the largest. Okay, to have something in common means that it's the same. So we're going to find the biggest number that is the same. And remember, a factor is two numbers that are multiplied together. So what we're going to do is we're going to take our whole numbers, we're going to break them down into the numbers that multiply to make the whole number. We're going to find the biggest one that is the same between the two numbers. So I'm going to show you how this works now. First, I want you to write these down in your notes, okay? A common factor is a whole number that is a factor of two or more non-zero whole numbers. We'll talk about what that means as well. The greatest common factor is the greatest of all the common factors. Again, this word doesn't mean that we're just going to pick our favorite. It means that we're going to pick the biggest of the common factors. Go ahead and pause as you need to take notes. So before we do this, we need to be able to take a number and divide it down to make the factors. So remember that division and multiplication are actually opposites. So divisibility is super important when finding factors because we need to be able to take a big number and divide it up to make it all the factors that make it. So we want to know, freaking out. A couple of things. So we pick a whole number. So we know if a whole number is divisible by 2, that whole number is even. So what that means is any even number, we know it can be divided by 2. So if I'm trying to find the factors of 32, because it's even, I know that 2 times something equals 32, which means that 32 can be divided by 2. So 2 goes into 3 once. We subtract, bring down our 2, we get 12. and it's 16. So I know 2 times 16 equals 32. So what we're saying here is that if a number is even, it can be divided by 2. If a number is divisible by 3, that means that the sum of its digits is divisible by 3. So take, for instance, 27, okay? We can tell if this is divisible by 3 if its digits added together, so the digits are 2 and 7, equals something that can be divided by 3. And we know that 3 times 3 equals 9, so we know 27 is actually divisible by 3. A number is divisible by 5 if it ends with a 5 or a 0. So if I have 25, it ends in a 5, so it's divisible by 5. If I have 235, it ends in a 5, so it's divisible by 5. Same with a 0. If it's 2010, it's divisible by 5 because it ends in a 0. Okay, 6 has 2 things that we need to know. If the number is even and it can be divisible by 3, it can be divisible by 6. If 2 and 3 are a no, then 6 is a no. So the number first off has to be even. So take, for instance, 27. This is not even, so it can't be divisible by 6, even though it is divisible by 3. So if we look at 30, it's an even number, right? So it's divisible by 2. So that's our first criteria for 6. Then we see 3 plus 0 equals 3. So the sum of the digits is divisible by 3. So it's divisible by 2 and it's divisible by 3. That means that it's divisible by 6. A 9 is similar, to a 3. If the sum of the digits is divisible by 9, the number is divisible by 9. So 3 plus 0 equals 3. 3 is not divisible by 9, so that means that 9 cannot go into 30 evenly. But 27, remember, we did 2 plus 7 equals 9. So 9 is divisible by 9, which means 27 is divisible by 9. And finally, our easiest one, the one that we should all know, gosh, this is really freaking out today, sorry, is 10. If it ends in a 0, you can divide it by 10. Easy squeeze. Any number that ends in a 0, 90, 900, 90,000. If it ends in a 0, it's divisible by 10. Okay. Moving on, some other things that we need to know before we can talk about factors is the difference between a prime number and a composite number. So write this down in your notes. Go ahead and pause your video, write it down. A prime number is a whole number greater than 1 whose only factors are 1 in itself. So this is a number that can't be divided by any number except for 1. So if we think about numbers like 13, 13 can't be divided by 2. It can't be divided by 3, 5, 7, 9. It can't be divided by anything. So the only numbers that can be multiplied together to make 13 are 1 and 13. That makes 13 prime because this is its only factor pair. Composite numbers are whole numbers greater than 1 that has factors other than 1 in itself. So if we look at something like 26, okay, we know that 1 times 26 equals 26, but it's even, which means that 2 times 13 also goes into it. So because it has more than one pair of factors, it's a composite number. 1 is neither prime nor composite. So 1 is itself, because if you think about it, 1 times 1, it actually only has one factor, which is 1. Everything else has 2 factors. My lights just went off. So now I want you to go up to the front desk and grab your prime number chart. Okay, everyone's going to have a chart that looks like this, and we're going to go through right now together, and we're going to cross off numbers that are prime. So what we're going to do is we're going to X off our composite, and we're going to circle our prime numbers. So first off, we just learned 1 is neither prime nor composite. So I'm just going to scratch that out. Okay, 2, the only numbers that go into 2 are 1 times 2. So that is a prime number. Same with 3, 1 times 3. Now 4 can be divisible by 2, so it's actually a composite number. 5, 1 times 5, that's it, so it's prime. 6 is even, so it can be divisible by 2, which means 2 times 3 and 1 times 6 go into it, so it's composite. 1 times 7 is my only factor pair for 7. 8 is even. And then 9 actually is divisible by 3. So 3 times 3 and 1 times 9, which makes its composite. So if you'll notice, from here on out, we actually can cross out all of our even numbers because 2 goes into them. So they're no longer alone, okay? There are some other rules that we can use as well, like tens. If it ends in a 0, it's divisible by 10, making it composite. So we're going to get rid of our entire 10 row. Okay, let's see what else. Even, so all of these can go away. This whole row can go away because they're all even. This whole row can go away because they're all even. And this whole row can go away because they're all even. Okay, the other row that can go away are 5s. Remember that if it ends in a 5, it's divisible by 5. So those are not prime. Okay, 11 is prime, 13 is prime, 17 is prime, and 19 is prime. Okay, the other direction we can go is this way. So 9, 18, 27, 36, 45, 54, 63, 72. All of these numbers, 81, 90, can be crossed off because they're divisible by 9. Let's see here. 21. 2 plus 1 is 3, so it's divisible by 3. 2 plus 3 is 5, so that's not divisible by 3. It's not odd, or not even. It's not divisible by 6, not 5. So that's a prime number. 29 is also prime. 31, prime. 33, composite, divisible by 3. 3 plus 3 is 6. 6 is divisible by 3. 37, that makes it 10, so prime. 39, 9 plus 3 is 12, and 12 is divisible by 3. 41, prime. 43, 4 plus 3 is 7, prime. 47 is 11, so that one's prime. 49 makes it 13, prime. 51 makes a 6. 6 is divisible by 3. 8. 57 would be 12, which is divisible by 3. 59 is 16, so that is a prime. 61, prime, prime, prime. 73, 10, so prime. 83 is 11, so prime. 9 plus 3 is 12, which means it's composite. 67 would be 13, prime. 77 is divisible by 11 because it's a double, so it's composite. 87 is 15, which is divisible by 3. 97 is 16, prime, and then I don't know if I can move me here. I can, look at that. 99 divisible by 11, so that one's out. 89, prime, prime, composite. Okay, so now we have our whole chart filled out. We can use this when it actually comes to finding greatest common factor. So the first way that we can find greatest common factors is by listing the factors. So we can do this by literally just listing out the pairs. 36, the first one that we're always going to list out is 1 times 36, because we know every number can be divided by 1 in itself. Okay, it's even, so it's divisible by 2. 2 times 18. 3 plus 6 is 9, so it's divisible by 9. or by 3, which is 3 times 6. 4, 36 times 4 is 9, and then 6 times 6 is 36. So we just list out those factors. The other way that we can list factors is by simply listing out our factor pairs like so. So instead of 1 times 36, we would have listed them 1, 36, 2, and 18, okay? Or we can list them by closing the curtain. This way makes a lot more sense to me personally. So with 36, we would say 1 and 36. So we go to opposite ends. We know 2 goes in, 2 pairs up with 18. 3 times 6. 4. Wait, this is wrong. This should be a 12. I'm sorry. That didn't make sense. 4 times 9 and 6 times itself. So when we list them out this way, it's actually really easy to see which ones we have in common, which is what we're doing next. Okay, the greatest common factor means that we find all of the factors that these numbers have in common. So they have 1, 2, 3, 4, 6, okay, 8 and 9, 12 and 12, 18, 24, and 36. So we find the common factors, and then the greatest common factor would be the biggest one that they have in common, which is 12. It's that simple, okay? Super easy. One way that we can do this is by listing out the factors. So we're going to try that now. I want to find the greatest common factor between 50 and 45. Pause, list out all your factors, and find your greatest common one. Okay, so it doesn't matter which way that we listed them. Again, I like to do closing the curtain. So 1 and 50, it's even, so I know 2 goes into it, and 2 times 25. 5 plus 0 is 5, which is not divisible by 3. 4 can't go into it, but I know 5 times 10 can. Starting to get close. 6 can't, 7 can't, 8 can't, 9 can't. So those are all my factors. I like to close the curtain with a line there to know that I'm done. Okay, 45 is 1 and 45. It is not even, so 2 can't go into it. 4 plus 5 is 9, and 9 is divisible by 3. So if we think about it, 3 would be times 15. 4 can't go into it, but 5 times 9 can. 6, 7, 8 can't. So, bam. Now what we do is we find our common factors. They both have a 1. Oh, that was sloppy. They both have a 5, and that is it. So of the common factors, which are 1 and 5, 5 would be my largest. Easy squeeze. So when we get bigger numbers, it actually can get a little bit more difficult, but it doesn't need to be. Okay? This is AKA the long way. So this is what we just did. Okay? You can list all of the factors for each number. Find the greatest common factor in the number. So if you would like to, please put this in your notes. Okay, we call this the long way because the bigger the number, the more factors it has, which means that it can take longer for us to actually list them out. But there is a faster way, and we can do this using prime factorization. We use a factor tree to make this diagram. And so what a factor tree is really just trying to find all of the factors and trying to get them down into prime numbers. So what we do is we start with, and I like to call this a Christmas tree, okay, because we're going to make it pretty. We start with one factor pair. That's all we have to start with. And I know that if it ends in 0, it's divisible by 10. So I know 10 times 18. Now, our goal is to take these numbers and to break them down all the way until they're prime numbers and they can't be broken down anymore, okay? So 10 and 18 can both be broken down more. So I know 10 is the same as 5 times 2. Now 5 is a prime number, so I'm going to turn it into a bulb. And so is 2. They can't be factored down anymore. So we're done with this branch, okay? 18 is the same as 9 times 2. 9 is not prime, but 2 is, so we're going to circle that one. Okay, and 9 can be broken down into 3 times 3, which are both prime numbers. So next, what we do is we relist all of these in alphabetical order. So we just want our Christmas bulbs, or not alphabetical, numerical. So what we're saying here is that 180 can be made by multiplying 2 times 2 times 3 times 3 times 5. So to figure out if we're right, we can actually do that, right? 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. And 36 times 5 is 180. So what we've done is we've factored 180. We've prime factorized 180. We've made it so that way the only numbers being multiplied together are prime numbers, and they still make 180. So we can use this to actually find our greatest common factors. So finding the GCF. First, we prime factor each number. Go ahead and pause this and write this down. We write out the factorization, which is what we just did right here. Okay, this is the factorization of 180. We want to do them in least to greatest. We circle the common prime factors. We write out the common factors with multiplication, and then we multiply to find the GCF. So I'm going to show you what this looks like. First, we are going to prime factor 64 and 120. So 64 is the same as 8 times 8. Those are not prime yet, so 4 times 2, 2 is prime, and 2 times 2, which are both prime. So this one's going to look the same, 4 times 2, 2 times 2. And we're going to write this out as a prime factorization. So 64 is equal to 2 times 2 times 2 times 2 times 2 times 2. Remember, we do not want to write this as exponents. Okay, 120 is the same as 60 times 2. 2 is prime. 30 times 2. 15 times 2. And 3 times 5, which are both prime. Then we write them in order. Okay, remember least to greatest. So there's 3 2s, 2 times 2 times 2, a 3, and a 5. So this is just what we did the last time, right? We prime factored our numbers. Now what we're going to do is we're going to see what they have in common. So there's a 2 here, a 2 here, and a 2 here. These are what they have in common. So we want to say what number is being circled. The number that's being circled here is a 2. So we're only going to write it once below. Okay? The number that is being circled here is a 2. The number that is being circled here is a 2. So 2 times 2 is 4. 4 times 2 is 8. 8 is our GCF. So this might be a little bit more complex, but once we get the hang of it, I promise that it works super duper easy. So it's up to you however you would like to find your greatest common factor, whether it's by listing 1 times 12, 2 times 6, 3 times 4, and 1 times 54, 2 times 27, 3 times, oh shoot. This is why I like to prime factor. Divided by 3 would be 1, 24, 3 times 8, so it'd be 18. 4, again, 54 divided by 4, so it'd be 1. But it can't, so no. 5, it can't. 6 does go into it. 6 times 9. 7 and 8 can't. And then we can find our common factors, 1, 2, 3, and 6. And then 6 would be our GCF. Or we can do this using prime factorization. So I'll show you how that works. 12 and 54 is what we are working on. So 12 would be the same as 6 times 2. 2 is prime. 3 times 2, both are prime. 54 would be 6 times 9 2 times 3, 3 times 3. And then we write out our prime factorizations. 12 is equal to 2 times 2 times 3. 54 is equal to 2 times 3 times 3 times 3. And then we find our pairs. So 2 matches up here, and they each have a 3. So the 2 is being circled here times the 3 is being circled here, and we get 6. So both ways we got a GCF of 6. It's just whichever makes more sense to you. So what I'd like you to do now is your assignment. I have decided that your assignment is actually 5 through 21 odd. Your assignment is up front or in your book, depending on what year this is. Please go ahead and work on that now. I will come up and do some practice problems with you soon. Please raise your hand if you have any questions at all. May the odds be ever in your favor.